There is something haunting about the way an object moves when no one expects it to matter. For months, 3I our Atlas drifted through the dark like a quiet traveler, a guest passing through our solar system without a sound, without a warning, without a single hint of what it carried inside. Astronomers watched it the way you watch a stranger cross a lonely road, curious but calm. Nothing about it seemed special at first. It was just another interstellar visitor, one more rock from another star, tracing a path we thought we understood. But the silence was the first clue. This kind of silence is different. Not the peaceful kind. The kind that hides something. Every week, the observatories updated their prediction charts. Everything looked normal. The same orbit, the same dim glow, the same cold body sliding through the ecliptic plane. If you looked at the early data, you would think this object was almost shy. It didn't flare. It didn't break apart. It didn't behave like a comet heating up. It simply moved, steady and quiet, as if it wanted to go unnoticed. Then, slowly, something changed. As 3I our Atlas drifted closer to perihelion, the point where the sun should have lit its surface with fire, the numbers began to shift. Not by much, not enough for the average person to care, but enough for the people watching it day and night to freeze in confusion. The object's reflectivity dipped, not randomly, not chaotically, but in a pattern so subtle that only the machines felt it first. It was like someone turning down a dimmer switch. Soft, controlled, intentional. Most comets brighten near the sun. Their ice melts, their dust erupts, and their glow wraps around them like a halo. But not this one. 3I our Atlas dimmed instead, almost like it didn't want to be seen. Like something inside it pulled the light into itself and hid it away. At first, the scientists blamed the instruments. A calibration error, a bad sensor, a glitch on the software that tracks the brightness curve. Because glitches happen all the time. They are easy to explain, easy to fix, easy to forget. But then the same dip appeared on observatories thousands of miles apart. Chile, Hawaii, Spain, Japan, all of them saw the same thing. The light curve didn't just drop. It dropped with the same timing, the same angle, the same depth. Every model predicted a smooth rise in brightness, yet reality showed the opposite. It was like watching a heartbeat slow down right before your eyes, even though nothing should be alive out there. Some researchers stared at the numbers longer than they should have, trying to find comfort in logic. They ran simulations again and again, hoping one of them would match what they saw in the sky. But nothing fit. Every scenario failed. Every explanation collapsed. And the more they looked, the more the question inside them grew. Why would an interstellar object dim itself near the sun? In quiet rooms, with screens glowing in the dark, they whispered possibilities. Some said the surface must be rougher than expected. Others said maybe the material was absorbing more sunlight than normal. A few suggested a layer of dust falling away in a strange direction. All theories, all guesses, none convincing. Because deep down, they all felt something they didn't want to admit. This didn't look natural. But no one dared say the other word. The one that sits in the back of the human mind like a shadow. Artificial. So instead, they focus on the patterns. Every drop in brightness followed a rhythm. Not random. Not chaotic. Almost deliberate. The timing between dips was too close. Too consistent. Too precise for a drifting rock that had traveled billions of years across space. It was like the object was breathing, or adjusting, or reacting to something. One astronomer described it quietly in his log. It feels like 3I Atlas is preparing for something. Another wrote, the dimming is not passive, it's controlled. But these lines stayed buried in personal notes, never spoken aloud in meetings. In science, no one wants to be the first to suggest something impossible. No one wants to risk their career on a feeling. So they waited, watching, studying, hoping the curve would return to normal and save them from the strange suspicion crawling up their thoughts. But the curve never returned. Night after night, the object sank deeper into its quiet darkness, even as the sun grew brighter around it. It should have been glowing like a lantern. Instead, it looked like it was closing its eyes. And the closer it moved toward perihelion, the stranger it became. Observers noticed small shifts in its rotation, tiny, almost invisible corrections, like a dancer adjusting their balance. Not enough to alarm the public, but enough for the experts to feel their chest tighten. Because natural objects drift. They wobble. They rotate freely. They do not correct themselves. Yet 3i, our atlas, moved with a kind of confidence, a kind of purpose, a kind of awareness, as if it knew exactly where it needed to be. In the control rooms, people started to stay longer after their shifts ended. They watched the data as if waiting for the object to do something else, something bigger, something that would finally make sense of the silent dimming. But nothing happened. Just more darkness, more quiet, more questions. The object kept approaching the sun like a traveler walking into a bright doorway, but instead of being lit from the outside, it looked like it was lit from within, faint, hidden, and almost shy. By now, some scientists felt a kind of tension they struggled to explain. It wasn't fear. It wasn't excitement. It was something in between, the feeling you get when you sense the world is about to shift, even if you don't know why. Because objects don't normally dim like this. They don't hide their own light. They don't change their brightness in ways that line up across the world, unless something inside them is controlling the show. But no one was ready to finish that thought. Not yet. Not this early. Not without more proof. So they kept watching, kept recording, kept pretending everything was normal. And as 3i, our atlas, entered the final days before perihelion, before the sun would force it to reveal whatever it truly was, one simple, quiet truth settled into everyone who studied it. This object wasn't silent. It was waiting, and whatever it was waiting for was getting closer. The first complete light curve of 3i, our atlas, arrived late at night, glowing on screens inside observatories scattered across the world. At first glance, it looked like any other data set, numbers, brightness points, a clean arc showing how light reflects off a moving object. But the moment scientists zoomed in, the room changed. Conversation stopped. Chairs froze. The gentle hum of machines suddenly felt louder, sharper, heavier, because the curve wasn't smooth. It wasn't natural. It was broken. Inside the clean arc, the brightness dropped in sudden, perfect steps, sharp vertical cliffs that cut downward like a machine switching off for a moment. Not a fade, not a gradual dip, just an instant fall, then an instant rise, again and again. It looked wrong. Too perfect, too controlled. One researcher blinked twice, thinking it was a display glitch. He refreshed the graph. The same drop. Another scientist pulled up a second telescope's data. Same pattern. A third checked data from the other side of the planet. Same dip, same timing, same depth. It was impossible. Natural objects don't behave like that. A comet doesn't turn its brightness off like a switch. Dust clouds don't form in perfect squares. Ice doesn't melt in 1-second intervals. But the light curve of 3i, our atlas, did exactly that. Sharp, clean, mechanical-looking steps, as if something inside the object opened and closed at exact intervals. 5 seconds on, 5 seconds off. Again and again. One astronomer whispered, "This can't be real," but the numbers didn't care what anyone believed. They kept showing the same cold truth. Each dip lasted the same number of seconds. Not a millisecond more, not a millisecond less. Someone suggested cosmic dust interference, but dust doesn't work on timers. Someone else suggested sensor noise, but sensor noise doesn't sync across continents. Another tried to blame the software, until a fourth observatory confirmed it using an entirely different system. The room grew quiet in the way only fear can make it quiet. Not the loud fear that makes people panic. The slow fear, the thoughtful kind, the kind where the world suddenly feels bigger than you thought it was. Scientists huddled over their screens, staring at the dips, each one perfectly rectangular, like a code being written in light. The shape was too clean, too sharp, too intentional. Natural signals have chaos in them. Noise, irregularity. But this looked engineered. Still, no one wanted to say the word signal. Not yet. That word carries weight. It changes careers. It changes reputations. It changes the way you sleep at night. So instead, people ask safer questions. Could the rotation be causing this? But rotation creates smooth curves, not square waves. Could it be jets of gas erupting from inside? But jets don't fire in perfect 5-second windows. Could temperature spikes cause the dips? But temperature varies slowly, not like clockwork. Every explanation collapsed the moment it was spoken. Then someone noticed something even stranger. The dips weren't just timed. They lined up with the object approach angle. It was almost like 3i our atlas dimmed itself each time it faced a certain direction, as if something on one side of its body controlled the brightness. It shouldn't have been possible. Yet the curve wasn't lying. The universe was. As the night went on, more observatories confirmed the same pattern. The dips weren't random artifacts from a single telescope. They were consistent across the globe. Every 5 seconds, a drop. Every 5 seconds, a rise. Perfect. Repeating. Almost calm. A senior astrophysicist finally said the quiet part out loud, in a voice barely above a breath. It looks like modulation. The room went still. Modulation is what happens when you control a signal. When you turn something on and off to send information. When you create a pattern with intention behind it. Stars don't modulate. Comets don't modulate. Rocks from another star system definitely don't modulate. Unless they aren't just rocks. But no one wanted to follow that thought. It felt like stepping too close to a cliff in the dark. So instead, they focused on the curve again, zooming in farther, looking for chaos, noise, irregularities, anything to make the dips look natural. They found none. Each dip rose and fell so cleanly that one scientist leaned back in his chair and whispered, "It's like someone flipped a switch." And once he said it, no one could unsee it. The pattern looked like binary. On, off, on, off. Light, darkness, light, darkness. A rhythm that didn't belong to nature's usual handwriting. Some stared at the data until their eyes blurred. Others paced back and forth, trying to breathe slowly. A few sat perfectly still, trying to understand what the universe was trying to say. Was this a malfunction of nature, or something else entirely? By sunrise, the question had settled into every mind in the room. Heavy, uncomfortable, and impossible to ignore. If this wasn't noise, and it wasn't an error, and it wasn't a natural phenomenon, then what exactly was switching the light of 3i our atlas on and off with such perfect timing? And why did it feel like the object was waiting for someone to notice? There was nothing unusual about the early thermal readings. 3i our atlas looked as cold as any interstellar object should be, a drifting shard of ancient ice, frozen for billions of years, untouched by any star. But then the deeper scans arrived, and every assumption scientists held about this object began to loosen, one quiet number at a time. Because the heat wasn't staying still. It was moving. It started as a faint warm patch on one side of the object. Just a small rise in temperature, nothing dramatic, nothing alarming. But the next scan showed that the warm patch had shifted slightly, sliding across the surface like something underneath was pushing it forward. Objects in space don't do that. Heat spreads. It doesn't travel. Not like this. More observatories joined in. Chile, Hawaii, Australia. Even instruments on high-altitude balloons caught the same pattern. The warm spot kept drifting, following a path too smooth to be random, too straight to be natural. It was like watching a spark crawl across metal, slow, steady, intentional. Then another warm patch appeared, and another, each one rising, shifting, cooling in perfect intervals. Scientists crowded around the monitors, watching the object's body light up in small pulses of infrared glow. It didn't flare up wildly like a melting comet. It didn't scatter heat in chaotic bursts. Instead, the warmth activated section by section, like compartments turning on, one after another, with the calm certainty of a machine waking from sleep. One researcher whispered, "It's cycling." Another said, "It looks like a system check." A third refused to speak at all, because the truth sat heavy on every screen. 3i our atlas wasn't heating randomly. It was heating in patterns. 5 minutes of warmth, 2 minutes of fading, 5 minutes of warmth, 2 minutes of fading, the exact same timing, on every observatory, across every data set. Someone suggested solar radiation, but the pattern didn't line up with sunlight. Someone else blamed gas vents, but gas vents don't warm the surface in perfectly timed waves. Another suggested micrometeorite impacts, until they realized impacts don't arrive on a stopwatch. Still, no one was ready to say the word internal. Because internal heat implies movement. Movement implies structure. Structure implies design. And design implies something nothing in the room wanted to believe. The longer they watched, the clearer the pattern became. Heat clusters formed geometric arcs, small, faint, but undeniably organized. They traced the curvature of the object like outlines of panels hidden beneath the dust. Each glowing arc seemed to respond to the last, almost like one part was signaling to the next. It felt alive, but not in a biological way. Alive in the way a machine is alive, obedient to some quiet purpose buried deep inside. As the hours passed, a new detail emerged. Every time a hotspot faded, another appeared on the opposite side, as if heat was being routed internally through something that moved it with intention. It wasn't melting. It was stabilizing, balancing, preparing. A senior scientist finally said it in a low voice, flat and steady, as if speaking it too loudly would make it real. "This is heat management." The room went still. Every heartbeat seemed to pause. Heat management is not a property of comets. It is a property of engines, of reactors, of machines built to survive extreme conditions. 3i Atlas should have been freezing or burning depending on its angle to the sun. Instead, it was doing something else entirely. It was regulating itself. The thermal maps kept updating, each one more unsettling than the last. The heat shifted like a pulse moving under skin. It seemed to travel along invisible pathways, long streaks, angled lines, curved routes that no natural fracture or icy terrain could explain. The object wasn't overheating. It wasn't reacting to sunlight. It wasn't behaving like rock or ice. It was behaving like something with a purpose. One researcher stared at the display until her eyes flooded, not from fear, but from the weight of the realization settling inside her. "We're not looking at a comet," she whispered. "We're looking at a process." But no one answered her, because answering would mean accepting the unthinkable, that something inside 3i Atlas was turning on, piece by piece, quietly, carefully, methodically, like a machine warming up. Just before sunrise, the sky still holds that quiet blue where night and morning blend together. It's the hour when most people sleep, but astronomers don't. And on this particular morning, 3 different observatories in Chile, South Africa, and Australia watched the same strange thing unfold at almost the exact same moment. A pulse, sharp, bright, too fast for the naked eye, but impossible to miss on the sensors. It lasted less than a second, a sudden spike in the brightness of 3i Atlas, like someone flashing a mirror toward the Earth. At first, each team thought it was their own equipment glitching. A loose wire, a passing satellite, a reflection of something floating nearby. Anything but the object itself. But then the calls started coming in. One observatory after another. Same pulse, same timing, same angle. 3 countries, thousands of kilometers apart. One identical spike. That shouldn't be possible. Natural objects don't flash and sing across half the planet. They don't coordinate their brightness like they are performing for an audience. And they don't wait for the exact second before sunrise, the moment when the sky is dark enough to see, but bright enough that most instruments are adjusting exposure. It was a perfect moment to hide something inside the light. The teams compared their data, overlays of graphs stretching across long screens. And there it was. The pulse lined up like a ruler had been placed across the plots. A perfect vertical jump. Same height, same shape, same millisecond duration. Even the noise pattern at the edges matched. One scientist broke the silence first. Once as noise, twice as weird, 3 times. That's intent. But intent from what? Or from whom? To make things stranger, the pulse repeated the next morning. Same timing, same brightness, same surgical precision. Not a minute early, not a minute late. It was as if 3i Atlas was waiting for the Earth to tane, watching for that thin blue line of dawn, and flashing only when it knew the world's telescopes were pointed at it. Some tried to explain it away. Maybe sunlight was catching on a spinning surface. But the pulse didn't match the rotation. It didn't match the object's known angles. It didn't match any physical model at all. A spinning rock doesn't blink. A comet doesn't send time flashes. Nature doesn't act like a lighthouse. Yet that's exactly what this pulse resembled. A signal sweeping across Earth's horizon. The data kept coming. Each morning, the spike appeared with the same cold precision, and with every new pulse, the unease inside the observatories deepened. Not fear, not yet, but the sense that something out there was aware of the geometry between object and planet. A few researchers whispered theories they didn't dare write down. Is it scanning us? Is it aligning with something? Is it responding to sunrise or waiting for it? One astronomer placed all three pulses on a global map. When connected, the lines cross over the highest density observation zones on Earth, places with the most telescopes, the most monitoring, the most human eyes watching. It was almost as if 3i Our Atlas was aiming its flashes directly where attention was strongest. A chilling thought began to form in the room. Not spoken, but felt. This didn't look like behavior. It looked like communication. Still, no one wanted to be the first to say the actual word, so they asked safer questions again. Could it be coincidence? Could atmospheric conditions create this? Could 3 different countries all glitch the same way? But the numbers refused to lie. The pulses were real. The pulses were timed. The pulses were synchronized. And if something is synchronized, something is controlling it. As the sun rose higher and the pulse faded into daylight, one question hung in the air of every observatory, heavy and electric. If these flashes are intentional. Intentional from what? It happens in the quiet hours, the kind of hour when the world feels half asleep and machines do most of the watching. A faint spike appears on a radio panel in a small observatory, so small it could be ignored, dismissed as background noise. But the technician on duty doesn't ignore it. He leans closer, narrows his eyes, and watches the screen flicker with a single thin line at exactly 18 centimeters. 18 centimeters. The hydrogen line. The same wavelength used to map the universe. He marks a timestamp, saves the file, and sends it to the main lab. He doesn't think much of it at first. Random radio lines show up all the time. Static, interference, Earth-based signals bouncing off the atmosphere. But something about the spike sits wrong in his mind. It looks too clean, too sharp. So he checks the logs again, and freezes. The spike occurred at the exact second the light pulse from 3i Our Atlas was recorded. He doesn't say anything yet. He just stares at the numbers, feeling his heartbeat slow down, the way it does when your mind catches something your mouth isn't ready to speak. The next morning, another observatory reports the same line, same wavelength, same brightness, same timing. And then a third. By noon, the data has reached research centers around the world, and suddenly no one is calm anymore. A hydrogen frequency radio line appearing in sync with a visual pulse is not something nature does casually. It's precise, coordinated, aligned across 2 different channels of observation. It shouldn't be happening, yet it is. Scientists huddle around screens, playing the radio signal on loop. It's not a voice. It's not a message. It's not even a sequence, just a faint, simple line riding above the noise. A whisper, if space had such a thing. But the human mind can't help asking questions it fears the answers to. Why now? Why this wavelength? Why in sync with the light? Some researchers argue it could be an echo, sunlight breaking hydrogen bonds on the surface. Others say it's a coincidence, nothing more. But coincidence doesn't repeat with this kind of precision. Coincidence doesn't match timestamps from 3 different continents. Coincidence doesn't rise and fall in perfect rhythm with brightness patterns already behaving like a heartbeat. Someone eventually voices what everyone else has been thinking. Are we hearing it, or is this just physics? No one answers. They can't, because both possibilities feel equally impossible. If it's natural, then the universe is doing something we've never seen before, combining light and radio in a synchronized pattern that defies every model. But if it isn't natural, if the signal is intentional, then 3i Our Atlas isn't just a visitor. It's something aware of how we watch, how we listen, how we measure the dark. The room grows heavier as the data keeps pouring in, hour after hour, whisper after whisper. The signal doesn't form words, but that almost makes it worse. The silence behind it feels deeper, more pointed, as if the object is choosing restraint or waiting for something. By sunset, the question still hangs in the air, soft but suffocating. Is 3i Our Atlas speaking? Or are we misreading a universe that suddenly feels far less familiar than it did yesterday? The next signals don't arrive loudly. They come the way quiet things always do, hidden, patient, almost shy. Buried inside the endless static of space, tucked between natural radio hiss and background cosmic noise, they slide into the data streams like faint breaths. Slow, soft, easy to miss unless you're already looking. But now everyone is looking. The radio arrays stretch across deserts and mountaintops, listening like giant metal waves press against the universe. And one by one, they begin to pick up something that shouldn't be there, tiny spikes so faint they vanish if you blink at the wrong moment. Yet they keep returning. Not random, not scattered, repeating. Technicians isolate the signals, peeling away layers of cosmic noise. What remains is thin, fragile, delicate, like an echo of something much larger, reaching across the void. Not a voice, not a message, just soft pulses, spaced with unsettling precision. The team starts plotting the signals on simple charts. No fancy models, no heavy mathematics, just raw timing. And that's when the room loses its air, because the pulses form a rhythm. A slow rise, a slow fall, a pause, then another rise. One scientist stays at the chart, rubbing his forehead like he's trying to wake himself from a dream. Another grips the edge of a desk, her knuckles white. A junior researcher whispers, "It looks like a heartbeat," and no one corrects him, because it does. A thermal rhythm, not random heat, not environmental noise. A pattern. Each peak lines up with a tiny rise in infrared readings from 3IO Atlas. Every drop aligns with the cooling intervals, and between them sits a silence so clean, so consistent, it feels intentional, like someone inhaling before speaking. Astronomers begin comparing the signals. Chile and Japan match. South Africa matches Spain. Australia matches both. Even orbiting satellites pick up the same soft pattern from above the atmosphere. The universe doesn't coordinate static like this. Natural processes don't keep time across thousands of kilometers. Something inside the object is doing that. Still, no one dares say it out loud. Calling it a heartbeat feels too alive. Calling it a system rhythm feels too artificial. So they choose safer words: cyclical activity, synchronized emission, repeating intervals. But each term skims the surface of a truth no one wants to touch. Late at night, one researcher overlays the radio pulses with the earlier thermal hotspots. The patterns fall into place like matching puzzle pieces, heat rising exactly when the signals rise, cooling when they fade. The alignment is so perfect that he pushes his chair back, stunned. The object is regulating something, controlling something, preparing something. The higher the signal rises, the hotter the hotspots become. The lower it drops, the surface cools like breath exhaled into cold air. It's not chaotic. It's not accidental. It's a cycle with purpose. But purpose from what? Some of the older scientists tried to reassure themselves. Maybe this is a new kind of interstellar chemistry, or rare thermal resonance, or a fracturing process we don't understand. But the younger ones don't look convinced. They've grown up in a world where machines whisper more than people, where signals shape reality, where intelligence doesn't always wear a biological face. And the rhythm coming from 3I Atlas, it doesn't sound chaotic. It doesn't sound broken. It doesn't sound like nature stumbling in the dark. It sounds steady, rising, waiting, like something inside the object is waking up and taking its first slow breaths. As 3I Atlas moved closer to the sun, everyone braced for the same moment, the break. This is what comets do. They crumble, fracture, shed their layers, and flare into chaotic clouds of gas. Heat tears them apart. Gravity stretches them. No object made of ice and dust survives a dive this close without falling into pieces. But 3I Atlas didn't break. It didn't crack. It didn't even tremble. It held together with a kind of calm strength that didn't belong to anything fragile or ancient. As solar light slammed into it, the object didn't melt. It brightened. Not randomly. Not unevenly. Instead, its surface lit up in straight, razor-clean lines that wrapped along its body like glowing seams. One astronomer whispered, "This isn't a comet." No one disagreed. Because natural objects don't glow in geometry. They don't trace perfect edges with light. They don't reveal shapes that look built, not formed. Across the world, telescopes zoomed in as far as their sensors would allow. The closer 3i our atlas got to the sun, the brighter those lines became, forming squares, angled segments, long parallel streaks that almost looked like panels heating under pressure. But pressure should have destroyed it by now. Every model said it should have torn apart hours earlier. The heat should have caused jets to explode from the surface, spinning it wildly. The tidal forces should have twisted it into shreds. Yet the object moved like steel in a storm, steady, controlled, untouched by the chaos around it. The geometric patterns kept expanding. A long vertical line lit up first, then a horizontal one, then a diagonal slash that connected them like a frame. It looked less like rock and more like structure. Scientists exchanged looks they weren't ready to translate into words. The fear wasn't loud. It was quiet, the kind that settles in your stomach when you realize the universe just broke one of its own rules. 3i, our atlas, wasn't behaving like a visitor struggling to survive the sun. It was behaving like something built to withstand it. And as the object glowed brighter, the question grew heavier. If these lines are not natural, then what exactly is holding this object together? As it dives into the fire without fear? As the dust around 3i our atlas thinned, the first thing everyone noticed was a light. Not the sunlight reflecting off a comet's surface, but something deeper, steadier, almost deliberate. The brightness didn't scatter the way dust usually scatters it. Instead, it wrapped around the object like a slow, glowing veil, and then, for the first time, the veil shifted. A small gap opened in the dust cloud. Just a moment, just long enough, and in that moment, something underneath became visible. At first, no one moved. Screens froze. Hands hovered above keyboards. It was a kind of silence that only happens when the mind is trying to reject what the eyes already know is true. Because beneath the dust, there wasn't the rough, uneven shape of a comet. There wasn't the jagged terrain of ice. There wasn't the porous texture of rock. There was a frame. Long, smooth, curved with intention. Not a natural curve, the kind created by spin or heat or pressure. This curve was clean, precise, like a line drawn with purpose. Observers zoomed in until pixels blurred, sharpening the image again and again, hoping it would dissolve into randomness. But it didn't. The angle stayed perfect. A pair of arcs ran along the body of the object, identical in shape, identical in distance, identical in symmetry. Nature doesn't do identical. Nature makes chaos. But this was order. Sharp, confident order. Someone whispered, "No." Someone else breathed, "It can't be." But no one dared finish the sentence. The dust shifted again, and the arc became clearer. It connected to another piece, a long, straight edge that ran parallel to its twin on the opposite side. Between them sat a shape that looked almost like a support beam, crossing the structure with a subtle, deliberate tilt. Rock doesn't form beams. Ice doesn't form matching arcs. Comets don't reveal frames. Yet here they were. Even the color felt wrong. Not gray. Not dusty white. Not charcoal. It had a muted metallic tone, a softness like brushed alloy warmed by distant light. The edges caught the sun in a way that rock never could, not reflecting wildly, but holding the light, shaping it. One astronomer leaned closer to the screen until her forehead nearly touched the glass. "It's symmetrical," she whispered, as if saying it too loudly would break something sacred. "Ice doesn't do symmetry like that. Not across two axes." Another voice added, "Look at the spacing. It's exact. Those arcs match by millimeters." The room went still again. The object rotated slightly, just enough to let the dust slip across its surface. As the veil moved, more of the hidden structure appeared, a spine-like ridge running down its center, flanked by the two arcs like ribs. The geometry kept repeating itself, lines, curves, intersections that didn't belong to chance. It looked like a skeleton. Not biological, mechanical, not alive, but designed to be. Someone finally asked a question none of them wanted to voice. "Are we looking at a hull?" No one answered, because answering meant stepping past a boundary the scientific world had never crossed before, the boundary between natural phenomenon and engineered object. The dust swirled again, covering the structure just as quickly as it revealed it. The frame faded back into the glow, disappearing into the haze. But the image was already burned into every mind in the room. A long body, smooth arcs, perfect symmetry. Metallic light. It wasn't enough to prove anything, but it was too much to ignore. As the dust settled back into silence, one truth lingered like a weight in the air. Whatever 3I Atlas is, it hides a shape inside the light that nature did not build. The infrared data comes in as a stream of soft red and orange lines, the kind of display scientists use every day without thinking twice. But tonight, those lines feel different. They don't flicker like noise. They don't scatter like natural heat. They rise and fall with a precision that makes the room fall silent. Because heat isn't just appearing on 3I Atlas. It's moving, not drifting, not spreading, moving. Across the body of the object, thin trails of warmth travel from one point to another like currents flowing through hidden channels. One hot spot ignites, then fades, then another lights up on the opposite side, then another, then another. The pattern looks less like thermal chaos and more like energy routing through an internal system, a machine's kind of movement, not a comet's. Scientists zoom into the infrared frames until the edges blur, watching the glow travel in steady paths. It doesn't pulse randomly. It doesn't scatter. The heat flows through the object the same way power flows through a circuit, controlled, guided, precise. One researcher whispers, it's distributing energy. Another answers, or managing it. No one corrects them, because both possibilities point in the same direction. Nothing natural behaves like this. Comets overheat unevenly. They flare. They burst. They crack open. 3I Atlas doesn't crack. It doesn't vent. The thermal maps show it dealing with solar heat the way a shield would, absorbing, shifting, releasing, stabilizing. Every rise in temperature is followed by a perfectly timed drop, as if some internal mechanism refuses to let any part grow too hot. It's not reacting to the sun. It's regulating itself. Each new skin deepens the unease. Bright veins appear under the surface, long streaks of infrared heat that look like channels built for energy flow. They are straight in some places, curved in others, bending around the frame revealed earlier. The geometry is too perfect, the alignment too purposeful. Someone overlays the thermal lines onto the structural arc seen before. The match is almost exact. Heat travels through the arcs, along the frame, around the spine-like ridge. This isn't geology. This is engineering. A senior astrophysicist finally breaks the silence. It's preparing. Nobody asks for what. Because the way the heat rises, slow, steady, building with intention, feels like something powering up. Something waiting for the right moment. Something testing its systems after a long, silent sleep. The object doesn't behave like a drifting rock. It behaves like a machine awakening and getting ready for whatever comes next. The radio line should have faded. Every model said it would. Object brighten as they approach the sun, then quiet down as they move away, like a fire dying after its last breath. But 3I Atlas didn't follow the rules of fading. It did the opposite. The signal grew stronger, not dramatically, not explosively, just a steady rise, hour after hour, like someone slowly turning up the volume on a whisper. What began as a faint line lost in the static now stood tall and sharp on every radiograph, impossible to ignore, impossible to explain away. At first, scientists thought their instruments were drifting. They recalibrated them, reset them, switched frequencies, but the signal didn't disappear. It only became clearer, cleaner, more confident. 18 centimeters. The hydrogen line. The universal frequency, the one the cosmos uses to mark itself. And now something was speaking on it. In control rooms across the planet, researchers watched the signal climb higher. The pattern didn't shake. It didn't wobble. It rose in perfect intervals, almost like someone was adjusting the power on the other end. Nature doesn't do that. Nature is messy, chaotic. But this signal, growing with such measured intent, felt anything but natural. One scientist stared at the rising line and muttered, "This is escalation." Another said, "It's responding to something." A third, more anxious than the others, whispered, "Calling home." No one laughed. No one brushed it off, because none of the natural explanations fit anymore. Cosmic background noise doesn't strengthen over time. Thermal radiation doesn't rise in perfect steps. Random emissions don't target the hydrogen frequency with this much accuracy. With every hour, The line grew bolder. The noise around it shrank as if the signal was pushing the static aside. It was claiming the channel. Some researchers began overlaying the signal increase with Earth-based transmissions, old satellite trails, deep space pings, even archive SETI data. None of them matched. None lined up. But one alignment did emerge. The signal increased after 3I our Atlas passed perihelion, exactly when the geometric lines on its surface glowed their brightest. It was almost like the object had absorbed energy from the sun. And now, it was using it. Theories swirled quietly in late-night meetings. Maybe it was mapping the solar system. Maybe it was scanning for something. Maybe it was simply waking up, strengthening its systems with every hour. But the most unsettling possibility hung like a shadow in the room. Maybe it heard something. Maybe it recognized something. Maybe the growing signal was a reply to a message we didn't know we sent. By evening, the radio line stood higher than ever, sharp, strong, unwavering. It pulsed softly, a slow beat rising and falling with eerie calm, as if the object had decided to reveal its presence, no longer hiding behind noise and distance. The question echoed in every control room, in every mind staring at the rising frequency. If this signal isn't fading, if it's getting stronger, then who, or what, is it trying to reach? The more scientists refined the trajectory models, the more the room filled with a quiet kind of disbelief, the kind that doesn't shout, doesn't panic, doesn't tremble. It just settles, like a cold realization resting on the back of your neck. Because every new calculation pointed to the same truth. 3I our Atlas didn't wander here. It came here. Its path wasn't the long, sloppy drift of a rock thrown across the galaxy by chance. It wasn't the chaotic arc of an object nudged by gravity, pulled by stars, shaped by time. The model showed something else, a line too straight, too clean, too deliberate, a journey with intention written into its angles. The object didn't just pass through our solar system. It aimed for it. One astrophysicist stared at the plotted line for almost an hour before whispering, "There's no random trajectory that produces this." Another leaned over his shoulder, tracing the curve with a fingertip. The point of entry, the timing, the angle, they all matched a targeted path. Not perfect, but close enough that perfection wasn't needed to make the truth clear. Something guided it here. But saying those words out loud felt dangerous, like stepping through a doorway you can't come back from. So the scientists kept quiet. They let the screen speak for them. They let the silence settle in the room like dust. And the silence kept growing. Because even as the radio signal strengthened, nothing else came through. No modulation. No encoded message. No pattern that could be interpreted as language. Just a single, unwavering line. Strong, steady, unchanging. A presence without a voice. Some believed the object was sending a message too advanced for us to decode. Others argued the opposite. Maybe we were hearing nothing but the hum of a machine meant for someone else. Something else. A signal not meant for Earth at all. But the quiet felt intentional. It wasn't the silence of absence. It was a silence of restraint. As the object drifted farther from the sun, the symmetrical arcs beneath its dust became clearer, the thermal pathways steadier. It continued on its path as if following instructions written long before humanity even existed. The emptiness around the signal felt like a decision, a choice to say nothing more than its presence, its heartbeat, its trajectory. One researcher finally said what everyone felt but couldn't frame. This thing has an origin, we just don't have a name for it. Because nothing about 3I our Atlas pointed to chance. Nothing pointed to nature doing what nature always does. Everything pointed to a purpose moving through the dark, a purpose that arrived in silence, and now left in silence, as if waiting for the moment humanity is ready to understand it. As 3I our Atlas drifted farther from the sun, the violent brightness of perihelion softened. The object slipped back into the darker regions of space, where sunlight thinned and shadows stretched long across its body. But even in the fading light, something unusual still glowed beneath the dust, the geometric frame. It pulsed faintly at first, like embers cooling after a fire. Then, slowly, it moved,